So in the last video, we got our first little glimpse at how average rate of change is going to relate to calculus. And I went, hopefully slowly enough, through an example where we figure out the average rate of change from some number to that same number plus h. All I want to do in this video is that exact same thing, except I want to switch up the function. It won't always be a polynomial like you see here, like x squared minus 3x minus 2. Sometimes the functions will just kind of look different. And you're like, yeah, whatever, who cares if it looks different? You just take the two x values, plug them in, figure out what comes out, throw them into this average rate of change formula, simplify, and you're done. Yes, but that simplification step can feel very different if we have a different function. When your function is a polynomial, it'll always be more or less like this example that we did right here. But if your function is not a polynomial, it'll feel a lot different. So I want to take you through a linear example, then another polynomial so we can kind of compare and contrast, and then I want to take you through a rational function and what's called a radical function and show you the little tricks that you'll need to simplify the average rate of change in all four of these cases so that that h in the denominator cancels out. And I know right now you don't understand why that's so important, but if you'll ever trust me on anything, trust me that canceling that h in the denominator will be the key to turning average rate of change into a calculus topic and getting us where we need to go in this class. So without further ado, let's figure out the average rate of change from 3 to 3 plus h of this function. Let's first do it just completely blindly. Put our head down and just use the formula that we have, get our answer, simplify, and call it good. The formula that we have for average rate of change is, well, average rate of change is just the slope of the secant line. And for slope, I'm thinking change in y over change in x, rise over run. So I want to take my two different x coordinates and figure out how much the x's change, and then take my two different y coordinates, which I'll denote as f of x2 and f of x1, and figure out how much they change. This formula has four different pieces that feed into it. Two of those four are given to me in the problem. x1 is the number 3, and x2 is the expression 3 plus h. Since I'm given the function f of x, I can figure out f of x1 by replacing x1 with what it's equal to, the number 3. So what is f of 3? Well, that's easy. F of x is 2/3 x minus 4. So f of 3 would be 2/3 of 3 minus 4. 2/3 of 3 is 6/3. In other words, 2. So I have 2 minus 4. I have negative 2. I got x1, I got x2, I got f of x1. There's just one more piece of missing information. It's f of x2. Well, to figure out f of x2, what I have to do is take x2, which is 3 plus h, and put it into this machine, f of x. This machine's defined up here. Just copy exactly what you see here, except change all the x's into whatever your input is, 3 plus h. So I got 2/3 of 3 plus h minus 4. I've got my four different pieces, x1, x2, f of x1, and f of x2. And I'm going to throw those into this formula right here, and I'll get my answer. Maybe I'll switch colors and do that over here so I got some room. The average rate of change is just equal to f of x2, which is 2/3 times 3 plus h minus 4, minus f of x1. F of x1 is negative 2, divided by x2, which is 3 plus h, minus x1, which is 3. Remember the big deal I made in the previous video about how this is going to simplify so nicely? Let's do that step. In the denominator, I got 3 plus h minus 3. Oh, hey, that's cool. The 3's canceled, I'm left with just an h. In the numerator, I have kind of a mess. Let's see if I can clean it up a little bit. If I get rid of these parentheses by distributing the 2/3 through, 2/3 times 3 is just 2. And 2/3 times h, I could write that as, I don't know, 2h over 3, or 2/3 times h, whichever you prefer. And then I still have this minus 4 right here. And then if I'm subtracting negative 2, that's the same as adding 2. This doesn't look like it's simplifying really nice. Let's keep working. Well, I got a 2, a minus 4, and a 2. Oh, cool. 2 and 2 is 4, minus 4 is 0. All those constants cancel out. So what am I left with? Well, I'd have 2/3 h up on the top, and I'd have an h down on the bottom. 2/3 times h divided by h, those h's cancel out. I got 2/3 over 1. In other words, just 2/3. Note, again, this h in the denominator that came from the difference of 3 plus h and 3 ends up canceling out to give me this answer 2/3. That's really, really important. At this point, we're done and we should probably move on to another function. But before I do, I just want to make the comment that we didn't have to do all this work to figure out this average rate of change. This function is linear. Its graph is just a straight line. And that straight line has a slope of 2/3. So since the average rate of change is just the slope of the secant line between 2 points on the graph, if we choose any 2 points on the graph and figure out the slope of the line connecting them, it's just the slope of this line itself. We knew this answer was going to be 2/3 before we did any of this calculation at all. Let's do another polynomial, maybe a little bit quicker. Given in the problem, I have x1 is 2 and x2 is 2 plus h. I need to know f of x1 and f of x2. To figure out f of x1, all I got to do is put x1, which is the number 2, into this machine. I get 2 squared plus 2 minus 5. 4 plus 2 is 6 minus 5. Sounds like 1. Then I got to figure out f of x2. To figure out f of x2, I put x2, which is 2 plus h, into this machine. Put 2 plus h into this machine, just copy what I see here, except change all the x's into 2 plus h's. So I got 2 plus h squared plus 2 plus h minus 5. That leaves me with 4 pieces. 1, 2, 3, 4. I throw those all into my average rate of change formula. I guess I should have used the letter G here, not the letter F. I'm a little lazy and don't want to re-record this video, so hopefully you'll let that slide. But since the name of my function was G, it really should say G of x1. Anyways, I take those 4 pieces and throw them into my average rate of change formula for a function G, which looks just like this, except G's in place here and here. And we'll see how it cancels. A little hint that I want to give you right now. Because simplifying and canceling will be so important, it's not a bad idea to simplify these 4 pieces before you put them into this formula. It just makes life a little bit easier. This one's already simplified, nothing we can do here, and this is just a number, so nothing we can do here. But this expression, it's not a bad idea to get in the habit of simplifying this before you put it into this formula up here. And the way you do that is you just kind of get rid of parentheses and combine like terms. So 2 plus h squared, think 2 plus h times 2 plus h, and then FOIL things out. You get 4 plus 2h plus another 2h, so 4h total, plus h squared. That's 2 plus h squared. Then you still have this 2 plus h here, and then you have a minus 5. And now let's try to combine like terms. I have an h squared, and then if I look at my h terms, I got 4 of them here and 1 more of them here, so I just have 5 of the h terms. And then if I look at the constants, I got 4 plus 2 more gives me 6 minus 5. Looks like that gives me 1. This expression here simplifies to this expression here. And with that simplification, it's a little bit easier to figure out our average rate of change. Average rate of change is g of x2, which in its simplified form is h squared plus 5h plus 1, minus g of x1, which is 1, as I see written here, divided by x2, which was given to me to be 2 plus h, minus x1, which was given to me to be 2. Because I did this simplification before the fact, this average rate of change expression isn't nearly as bad as it was in this video, where I didn't do the simplification until after I put it into the average rate of change formula. Just a little hint. Anyways, let's simplify this guy. I claim that the denominator always simplifies to just the letter h. Does that happen here? Yeah, absolutely. 2 minus 2 is 0, so I'm left with just an h on the bottom. The numerator always simplifies to the point where you can cancel out this h. Does that happen here? Absolutely. Plus 1 and minus 1 cancel out, so I'm left with just h squared plus 5h. I have an h in all of the terms in the numerator, so I can factor out an h, and I'd be left with h plus 5. Divide that by h, the h's cancel, and I get h plus 5 as my answer. Coincidentally, the exact same thing I came up with up here. Just a coincidence. That won't always be the end. But the method that we did here was really similar to the method that we did above. Expand your polynomials, combine like terms, cancel, factor, and cancel, and you get your answer. H plus 5 in this case. That answer is really powerful. There's a lot of meaning hidden in this expression, but we're ignoring all that for now. We need to learn more tools before we can really appreciate the importance of this answer. For now, all we're doing is we're going through and we're simplifying things algebraically. So let's do another one. Here's a different looking function. It's what's called a rational function. Looks like a fraction kind of. Let's figure out the average rate of change of this rational function from 5 to 5 plus h. Sure, that's telling me that x1 is equal to 5, and it's telling me that x2 is equal to 5 plus h. If I have the two x values, I can figure out the two h of x values. By just taking x1 and x2 and plugging them into this machine. So first x1. x1 is the number 5, so I need to figure out what h of 5 is equal to. H of 5 I get by just copying exactly what I see here, except changing all the x's into 5's. So it's 2 divided by 5 minus 4. 5 minus 4 is 1, so it's 2 divided by 1. And when you divide by 1, well, you just get 2. What about h of x2? Well, x2 is 5 plus h, so I need to figure out what comes out of this machine when I put 5 plus h into it. Well, if I copy exactly what I see here, I got 2 divided by, and then instead of writing x, I'm going to write the input 5 plus h, and then I'll subtract 4 from that. That's kind of an ugly looking expression, but it simplifies a little bit. 5 minus 4 is 1, so I get 2 divided by 1 plus h. I got x1, x2, h of x1, and h of x2. I got the 4 pieces that I need for my average rate of change formula. I'm going to plug them into the formula and make sure that the things that I claim always happen, h in the denominator, h is canceling out, still happen. Let's start with the bottom. x2 is 5 plus h. From that, I want to subtract x1, which is 5. So I got 5 plus h minus 5 down on the bottom. That's looking really promising. In the top, I got h of x2, which is this 2 divided by 1 plus h. And from that, I want to subtract h of x1, which is the number 2. The top's going to be kind of hard to simplify, so I'm going to leave it alone for now. 2 divided by 1 plus h minus 2. The bottom's going to simplify really nicely. This 5 and this negative 5 cancel, and I get here. It's tempting to look at this and be like, let's cancel out these h's. Yeah, that'd be great. It would make it really simple, but that doesn't work mathematically. What we instead need to do is make this a fraction divided by a fraction, because we have a method for dividing two fractions. It's called multiplying by the reciprocal of the denominator. How do I make this a fraction divided by a fraction? Well, to make the bottom a fraction, it's really easy. H as a fraction is just h divided by 1. Just like 10 as a fraction is 10 divided by 1. You divide by 1 to change a whole number into something that looks like a fraction. What about the numerator where I have a fraction minus a number? How do I make that all one fraction? Well, depending on your level of comfort with fractions, you may be able to subtract these guys if they were both fractions instead of a fraction and a whole number. So what I'm going to do is I'm going to change this 2 over here into 2 divided by 1. Now at least it looks like a fraction. Okay, but where do I go from here? Well, I'm trying to subtract these two fractions to make them a single fraction. The problem is they have different denominators. Maybe you remember, and I know this is asking a lot, that you can only subtract fractions if they have a common denominator. So what we have to do is make this fraction have the same denominator as this fraction. The way we do that is we multiply the top and the bottom of this fraction by 1 plus h. It's important that we do that to the top and the bottom so we don't change the value of this fraction. But by choosing 1 plus h, now the denominator here is 1 plus h and the denominator is here is 1 plus h. And since I have the same denominator, I can subtract those two fractions. So what do we have here? We have 2 over 1 plus h. And from that, we want to subtract 2 times 1 plus h. In other words, 2 plus 2h divided by 1 plus h. Don't forget that down on the bottom, we still have this h divided by 1 to deal with later. Because we have the same denominator, we can subtract those fractions. Think if this were like, 5 sevenths, and we're subtracting 2 sevenths. How would you do that? Well, you'd leave the sevenths the same, and you do 5 minus 2, and so you got 3 sevenths. Right? 5 sevenths minus 2 sevenths is 3 sevenths. It's kind of the same idea here, except they're not sevenths, they're 1 plus h's. You subtract the numerators, and you leave the denominator alone. So I got 2 minus 2 plus 2h up in the numerator, and my denominator, the common denominator, is 1 plus h. Down in the bottom of this whole thing, I have h over 1. Our goal is to cancel out this h that was down in the denominator that I'm writing as a fraction now. We still can't do it based on how this is written, but we're actually getting pretty close. If we get rid of the parentheses up here, we take this negative and distribute it through. I got 2 minus 2h up top, and that's getting divided by 1 plus h, and that's getting divided by another fraction, h divided by 1. But the top of this top fraction, things work out really nicely. 2 minus 2 is just 0. So up top, I have negative 2h divided by 1 plus h, and on the bottom, I got h over 1. Finally, after doing all of this work, I've managed to rewrite this as a fraction divided by a fraction. And there's a way to divide fractions. What you do is you change it into multiplication by flipping the bottom one upside down. So I take the top one, this negative 2h divided by 1 plus h, and instead of dividing that by h divided by 1, I'm going to multiply that by. Can't be h over 1 because then I'm just switching division into multiplication. It's got to instead be 1 over h. If I haven't lost you in this algebra yet, you're home free. Because now a nice thing happens. We can cancel over multiplication. We could not cancel this h and this h because of this addition. But because of this multiplication, we can cancel this h and this h. Remember, this h right here came from this h right here, which is this h right here, the one that I was trying to get rid of from the very start. So, much like the previous examples, when I got my expression for average rate of change, I was left with just an h in the denominator, and if I did enough simplification up in the numerator, I managed to cancel out that h. And this isn't just practice algebra. The ability to cancel out this h is absolutely necessary for calculus. So what does this thing end up looking like? Well, this h is gone, so I got negative 2 times 1. In other words, negative 2. And then down in the bottom, I got 1 plus h times 1. In other words, 1 plus h. My answer for the average rate of change of this function from 5 to 5 plus h is this expression right here. I know that's a lot. For some people, you're like, yeah, that's easy. I learned all this subtracting fraction stuff years ago. This is cake for me. No big deal. For most people, you're like, I haven't subtracted fractions in years. There's these things called calculators that I use instead. I don't remember anything about common denominators and how to divide fractions and all of that. Yeah, that's a downside with doing a lot of arithmetic with the calculators. You kind of lose some algebraic skills. And then when you need to do algebra to simplify things, you might not have the ability. But don't worry about it. If you follow this now, great. And if you don't, we'll get a lot more practice doing things like this. There's really 3 different types of problems we're going to encounter in this class. There's the polynomial type, which you can think about these linear ones as a special case of. There's the rational function type, where we have to do all this mess with fractions like we just saw. And then there's the radical function type, where we're going to have to do one more trick. I want to show you that trick, and then I'm going to call this video good. We have another function. We have 2 different x values. x1 is the number 3. x2 is the expression 3 plus h. I need to figure out j of x1, which is just j of 3. It's just what comes out of this machine when I put 3 into it. Well, what comes out when I put x in is the square root of 2x minus 5. So what comes out when I put 3 into it is 2 times 3 minus 5. 2 times 3 is 6. 6 minus 5 is 1. So it's the square root of 1, which is just 1. That's not too bad. Yeah, it gets uglier though. J of x2 is going to be j of 3 plus h. J of 3 plus h, much like j of 3, I get from staring at this expression right here and changing all the x's into 3 plus h's. So I'd get the square root of 2 times 3 plus h minus 5. Not a whole lot of simplification you can do with that, but you could get rid of these parentheses now if you felt like it. 2 times 3 plus h is 6 plus 2h if you distribute the 2. And then that 6 minus this 5 leaves you with the 1. So I get 1 plus 2h when I distribute this 2 and collect like terms. I now have the 4 pieces that I need for my average rate of change formula. So plugging them into that expression will be easy. What will be hard will be simplifying that expression. But we'll get there when we get there. The average rate of change is the difference in the 2 y coordinates, j of x2, the square root of 1 plus 2h, minus j of x1, which is just the number 1, divided by x2, which is 3 plus h, minus x1, which is 3. Note that just like in every other example we've seen, down in the bottom here, the 3's cancel and I'm left with just an h. Not a coincidence, that always happens. Canceling out that h will be the goal of my simplification. It's tempting to be like, this 1 and this negative 1 cancel, maybe? And then maybe I can kind of get rid of this h and this h? No and no. This 1 and this negative 1 don't cancel because this one's underneath the radical. So we can't cancel out this h immediately. But fortunately, there's a trick. There's no reason for you to know this trick, and that's why I'm telling it to you right now. When you're in this kind of third type of problem where you have a radical function, where you got square roots, to cancel out the h, you're going to have to get rid of that square root. How do you get rid of that square root? What a lot of students like to do is square the top and the bottom of the fraction. You can't do that. That changes the value of the fraction. Think about a fraction like, 1/2. If you square the top and the bottom, that fraction becomes 1/4. 1/4 is not the same as 1/2. You can't just go squaring the top and the bottom. But what you can do is this trick called multiplying by the conjugate. It sounds worse than it is. Anytime I'm in this case where I have a radical and then a number that's not underneath the radical, what I want to do is write the radical again, so the square root of 1 plus 2h, and then write the number again, so 1. And if there's a minus in between those two things, I want to change it to a plus. If there was a plus in between those two things, I'd change it to a minus. That's what's called the conjugate of this thing. It's the same thing, just change the minus to the plus. Note that underneath the square root there was a plus. We don't change that to a minus. There's two terms, one that's underneath the square root and one that's not. The sign of the thing in between the two terms is what you change from negative to positive or positive to negative. If I'm going to multiply the top by the square root of 1 plus 2h plus 1, in order to not change the value of the expression, I have to multiply the bottom by that exact same thing. So since I put a plus 1 here, I want a plus 1 here. Doesn't look like anything's getting simpler at all, but it actually is. A nice thing happens when you multiply an expression by its conjugate. I have two terms here and two terms here, so I have to FOIL. Right? The F in FOIL would be the product of these two. The O in FOIL would be the product of these two. The I would be the product of these two, and the L would be the product of these two. But look what happens. The F, the square root of 1 plus 2h times the square root of 1 plus 2h, anytime you multiply the square root of something by itself, you're squaring the square root. Those cancel out, and I'm left with just 1 plus 2h. That's the F in FOIL. That's this times this. What about the O in FOIL? Well, that's going to be this square root times positive 1. But I'm not even going to bother writing that because the I in FOIL is going to be almost the same. It's the same square root times negative 1. And that's not a coincidence. Because I'm multiplying by the conjugate, the O and the I terms will always be the exact same. Just one of them will be positive and one will be negative. So those will cancel each other out. The O and the I in FOIL cancel out. I don't even need to write them. What about the L in FOIL? The negative 1 times the positive 1? Well, negative 1 times positive 1 is negative 1. This mess of a numerator simplifies all the way down to this, which is awesome. The denominator doesn't simplify that nicely, but you don't need to simplify the denominator. Leave the denominator as a product anytime you're doing one of these problems where you have a radical function. What I'm saying is don't try to get rid of these parentheses. Don't try to distribute the h into the parentheses. Just leave it as h times the square root of 1 plus 2h plus 1. Why do you want to leave it like that? Because this h is this h, which is the h that is in the denominator that we're trying to get rid of. We don't want to hide this h because our whole goal is to get rid of this h. Don't hide it by distributing it into the parentheses. Leave it by itself so that we can cancel it with 1 up in the numerator. Is there going to be 1 up in the numerator? Yes, and it's not a coincidence. This 1 and this negative 1 cancel out, and I'm left with 2h up in the numerator, and this h right here can cancel with the h that I have down in the bottom because I have multiplication. This is 2 times h, this is 2 times all this stuff, and you can cancel over multiplication. So these two h's cancel out, and my final answer is just 2, what's left up top when the h's are gone. Maybe it helps to see them with like a line through it or something. Divided by the square root of 1 plus 2h plus 1. You might look at this and think we're not done because there's still an h down in the denominator, but actually we are done because it's okay to have an h in the denominator. It's just this h that's originally in the denominator that has to cancel out. And we've canceled that out because it went over here, and then it went over here, and it canceled with this h up here. You're probably overwhelmed by all this algebra. If you don't teach math for a living, especially examples C and D are really challenging, but I got good news for you. There's not an example E or an example F or G. There's not a bunch of other types of functions that you'll have to worry about simplifying using this average rate of change stuff. Functions in our class will come in one of 3 flavors. This flavor that you saw up in A and B, this flavor that you see in C, and this flavor that you see in D. And yeah, you've only seen one example of a rational function and one example of a radical function. But the good news is the methodology, the way you simplify in this class will be very similar to what we do here. Making it a fraction divided by a fraction, flipping things upside down and canceling. And the way you simplify any radical function will be very similar to what we did in green here. It'll involve this little conjugate trick. And it'll feel really weird the first time you do it, but you'll get a little bit of practice and you'll be good to go. And when I ask you questions on quizzes and midterms, they will look a lot like one of these 4 examples, I promise.